Welcome to lesson number 2. We're going to talk about factorial notation and permutations. Now, I think the best way to talk about this is to think about the fundamental counting principle. And so if we were thinking about 6 times 5 times 4 times 3 times 2 times 1, that would just be the different ways that we could organize something with six objects or the number 6 in them. Another way we can write this, though, is by saying 6 factorial. In math, an exclamation mark like this is known as the factorial sign. So 6 times 5 times 4 times 3 times 2 times 1 is also known as 6 factorial. So without using a calculator, determine the value of 4 factorial. Well, this would be 4 times 3 times 2 times 1, where 4 times 3 is 12 times 3 times 2 is 24 times 1 is 24. 3 factorial would be 3 times 2 times 1 times 2 times 1, or 12. 6 times 2. Now, 6 factorial can be written in a few different ways. We can write it as 6 times 5 times 4 times 3 times 2 times 1, as we were doing in the previous lesson, or we can throw in the factorial sign in there and say 6 times 5 times 4 times 3 times 2 factorial, because this would be 2 times 1, or times 3 factorial, which would be 3 times 2 times 1, or 4 factorial, or 5 factorial, and so on. So using the table above, we can then simplify quotients such as 6 factorial divided by 4 factorial. So 6 factorial divided by 4 factorial, we could rewrite it as 6 times 5 times 4 factorial divided by 4 factorial. That would equal 1, and we would just be left with 6 times 5, and that's equal to 30. Now express 5 factorial as a product in 4 different ways. Well, 5 factorial we could say is 5 times 4 times 3 times 2 times 1, or 5 times 4 times 3 times 2 factorial, or 5 times 4 times 3 factorial, or 5 times 4 factorial. Complete the following. 12 factorial would be equal to 12 times 11 factorial. 8 factorial would be equal to 8 times 7 times 6 factorial. Now, we can also express factorials as quotients, so as products of division. And so 6 times 5 times 4, well, 6 times 5 is 30, times 4 would be 120. We could also describe that as 6 factorial divided by 3 factorial. 15 times 14 times 13 times 12. We could say 15 factorial divided by 11 factorial. Now this is just going to be something that you'll end up getting better at doing, but what I did in this first example is 6 times 5 times 4. Remember that 6 factorial can be written as 6 times 5 times 4 divided by 3 factorial, but 3 factorial, and I could cancel those out. And I did the exact same thing over here. I just went 15 times 14 factorial divided by times 13 times 12 times 11 factorial divided by 11 factorial, and we're left with the same thing there. Now again, without using a calculator, simplify the following question. 10 factorial divided by 7 factorial, I'd be left with 10 times 9 times 8 times 7 factorial, and I'll leave that as 7 factorial, and those would cancel out. 10 times 9 times 8, we would have 720. 8 factorial divided by 5 factorial times 3 factorial. I would have 8 times 6 times 8 times 7 times 6 times 5 factorial, and I'll have 5 factorial times 3 factorial, which is 3 times 2 times 1. 3 times 2 is 6, so those would cancel out as with that, and I'd be left with 8 times 7, or 56. Now, what we were just working on is what's known as factorial notation. And factorial notation can be expressed as nth factorial is equal to n times n minus 1 times n minus 2 times n minus 3, and so on, where 3, 2, 1, and where n has to be an element of a natural number. So let's look at some examples. N factorial, if we look at the above, is equal to n times n minus 1. N plus 2 would be equal to n plus 2 times n plus 1 times n factorial. N minus 4 times n minus 6, or sorry, n minus 5 times n minus 6 would be equal to n minus 4 factorial. So it's each time it's progression, it's making the progression downwards or upwards if we look at the constant term. Now simplify the following expressions and leave the answer in product form where appropriate. So express it essentially as a binomial. N plus 2 factorial divided by n factorial. So with these questions, it's best if we were to simplify them, and then simplify them in such a way where we're left with terms that we can cancel out. So n plus 2 factorial we could write as n plus 2 times n plus 1 times n factorial, and there's the term that we'll be able to cancel out, and we can leave this as in product form as a binomial, n plus 2 times n plus 1. And we'll do the same thing here. Let's look for a term we can cancel out. So n minus 2 factorial divided by n minus 1 factorial. Now if we look at the above, the factorial notation, we can write this as n minus 1 times n minus 2 factorial. We can just expand that, and that would be 1 over n minus 1. Next we have n factorial, and just like in typical factorial notation, this can be written as n times n minus 1 times n minus 2 factorial, and divided by n times n minus 1. There's the terms that will cancel out, and we're left with n minus 2 factorial. And we can actually leave, this is still product form, so we can leave the answer as factorial. Now, algebraically solve the equation n factorial divided by n minus 2 factorial is equal to 42. Just like we were doing before, it's best if we can get this into terms where we'll have cancellation. And so I have n factorial is equal to n times n minus 1 times n minus 2 factorial divided by n minus 2 factorial. Those will cancel out, and that equals 42. So now I'm left with n times n minus 1 is equal to 42, or n squared minus n equals 42. If I want to solve for my values of n, I'll just bring my 42 over. N squared minus n minus 42 is equal to 0. Now this becomes something that I can actually factor. Now, so two integers that multiply give me negative 42, but add to give me negative n. So I'll choose positive 6 and negative 7. And I get two values of n. N is equal to negative 6 and n is equal to 7. But remember that n has to be an element of natural numbers, and so we're going to go with n is equal to 7. Alright, so we were doing all of this without our calculator, but there's actually a factorial function on your calculator in the probability section. So the factorial key is you find it under the math section. So if if I choose the math option and I go all the way over to probability and choose option 4, that's the factorial button. And so let's try 4 factorial, because that's what we were using with everything else as our example. 4 factorial, choose option 4, we get 24 as an answer. So let's try these two questions here. So 6 factorial, type in 6, go over to probability, option 4, get 720. 9 factorial, all the way to option 4, and I get 362,880. So that's 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Now to simplify a quantity like 10 factorial divided by 7 factorial times 3 factorial, we can also do this on a calculator. So we would evaluate the numerator and the denominator separately, and then we would divide or enter it in one calculation using brackets. That's very important. So the first thing we could do is we would do it separately. So I'd go 10, option 4, and then I would divide 7 factorial times 3 factorial. But this isn't actually the right answer, because it's going this number divided by 7 factorial, and then it's multiplying that final answer by 3 factorial. So what we'd have to do is let's do them separately. So 3,628,800. So that was 10 factorial divided by 30,240, and I get an answer of 120. So that's the correct answer. Now, this is where brackets are important. So notice how I put 10 factorial in a bracket, and then I'm going to divide by a double bracket here by 7 factorial and multiplied by 3 factorial and with double bracket, and I get 120. So before I only used one set of brackets, and I ended up with my quotient, and then I found the product of that quotient, which is not the right way to go about it. Now verify without using a calculator. Well, we could go 7 factorial, and those would cancel out. 10 times 9 times 8 is 720, divided by 6 would be 120. All right, so you can do example 4, but let's look at permutations in the next section. So let's look at this example. An internet site access code consists of 3 digits. Knowing the 3 digits is not enough to access the site. The digits have to be entered in the correct order, and the order of the arrangements of the digits is important. And so this guy can't remember his code, except he remembers that it contains 3, 5, and 7. So what are all the possible arrangements that we could have of 3, 5, and 7? Well, we could have 3, 5, 7. We could have 3, 7, 5. We could have 7, 5, 3. We could have 7, 3, 5. Or we could have 5, 3, 7 and 5, 7, 3. So we got 6 possible arrangements for these three numbers. Now, this is what is known as a permutation, where there is a certain type of arrangement, but order is important. So a permutation is an arrangement of a set of numbers in which the order of the elements is important. So let's look at a few examples. Now, let's look at this first example. How many ways can you arrange the word cat? Well, you could have C-A-T, you could have C-T-A, you could have A-T-C or A-C-T, or we could have T-A-C or T-C-A. So there's 6 different ways. Let's write the number of permutations in factorial notation. Well, this would be 3 factorial. 3 times 2, 3 times 2 times 1. Just like we're doing with the fundamental counting principle. So this is just the example of the general rule that the number of permutations of n different elements taken all at a time is n factorial. All right, so there's 3 letters, which means that would be 3 factorial. So if we look at determine the number of permutations for the letters of each word, Regina, there's 6 letters, so that would be 6 factorial. That equals 720, like we looked at last example. At Kelowna, we have 1, 2, 3, 4, 5, 6, 7. That would be 7 factorial. And you can type that in your calculator to get the number of permutations there is for those letters. Now, permutations of n different elements taking r at a time, where r has to be less than or equal to n. So let's look at what that actually means. So we want to use the fundamental counting principle here to determine how many 3-letter arrangements can be made from the letters of the word graphite. So graphite has 1, 2, 3, 4, 5, 6, 7, 8 letters involved. And so in this example, we find that there's going to be 8 elements. So elements is going to be n. And we only want 3 or r at a time. So this is denoted by 8p3. All right, p meaning permutations. Now 8p3 is equal to 8 times 7 times 6 times 5 over 5 permutations, or 8 factorial divided by 8 minus 3 factorial. So this is because the general rule here is that if we have npr, we have n, which is our number of factorials, and or we have n, which is our element, and then we have r, which is how many of those are going to be taken at one time. So here we want to use the NPR key on our calculators. And so if we go over, that is right here. So we first would want to type in 8 and then NPR. And then we would want to verify that using our factorials. So let's use 8p3. So 8, and that's option 2, p3, and I get 336. So 8p3, the next thing we want to do is verify using our factorials. And so let's see if we get the same answer. So 8p3 is equal to 8 factorial divided by 8 minus 3 factorial, which we could say is 8 factorial over 5 factorial, or 8 times 7 times 6 times 5 factorial divided by 5 factorial. Cancel those out, and we get the same value of 336. If I check this, 8 times 7 times 6. Perfect. Now, if we replace r by n in the previous formula, we get the number of permutations of n elements taken at any time, and this is known as the nth factorial. Now, if we have n permutations n, then what we end up having is n factorial divided by 0 factorial. This is going to be equal to n factorial, and the value of 0 factorial must be 1. So 0 is going to be defined to have a value of 1. 0 factorial, that is, not 0 itself. All right, so let's look at example number 6 here. So inter-region vehicle license plates consist of 2 different letters followed by 4 different digits. If the letters I, O, Y, and Z are not used, so that's 4 letters out of the 26 in the alphabet, determine how many different license plates are possible by the fundamental counting principle. All right, so I have 1, 2, 3, 4, 5, 6 different digits, and let's read this very carefully. So it consists of 2 different letters followed by 4 different digits. If the letters I, O, Y, and Z are not used, determine how many different license plates are possible. All right, and so because we can't use the first four, and I'm going to assume we can't have doubles of the same letters, then we're starting off with 22. And since that first one is going to be taken next, we'll only have 21 letters to work with. Now we have two different letters, check, and followed by 4 different digits. So with those 4 different digits, I will have 10, and then I got 9, 8, 7. So 22 times 21 times 10 times 9 times 8 times 7. I get an answer of 328,480. And if I do this using permutations, I have 22, and 2 of those 22 times 10 P4 22 brackets 22 math 2 here, 2 times 10 math button, option 2 B4, and it checks out. So 2,328,480. Now if we're looking at this, where do all these numbers come from? So I know that the first number I had was 22, and 22 is because I had 4 letters of the alphabet that couldn't be used, and there's 2 different letters that I could arrange from my 22 available letters of my alphabet. And then secondly, I had 10 numbers or 10 digits that I could also use. And I had 4 different digits or 4 different ways to arrange those from, which is why I used 10 and 4 in my permutations there. Next, algebraically solve this equation. I'm just going to start it out for you, but you can finish it. If I have n minus 1 p2, what is that going to be if I arrange that as a factorial? Well, n minus 1, that becomes my value of n as a factorial. 2, remember, it's n minus n factorial, so that would be n minus 1 minus 2 factorial, which is equal to n minus 1 factorial divided by n minus 3 factorial. And we could simplify this even further to give us n minus 1, n minus 2, n minus 3 factorial divided by n minus 3 factorial. And those will cancel out, and we'll be left with n minus 1 times n minus 2. And we could say that n minus 1 times n minus 2 is equal to 90. And now it's an algebraic expression or quadratic equation that you can solve.